This lecture discusses the Kaplan-Meier estimator, or the KM estimator. So what is Kaplan-Meier estimator and what it does? Well, it is a non-parametric estimate of the survivor function, uppercase S of t, okay? Which is the probability of survival past time t, or equivalently the probability of failing after t. So let's say for a data set with observed failure time denoted by subscript T1, T2 to Tj, okay? And uppercase J, that is the last distinct failure time, where J is the number of distinct failure time observed in data. Then we can estimate the survivor function by using this formula. Okay, so here is a pi, uppercase pi, yeah, right? For multiplying what? Okay, so we have nj minus dj over nj for tj smaller equal to t, okay, this specific time point. So what is nj? Nj denotes number of individuals at risk at time tj. Okay, so total number of individuals at risk of failure at time tj. Right? What is dj? dj is the number of failures at time tj. So when we take a difference of nj and dj, okay, that's going to give us roughly the number of people who survive this tj, okay? And over nj, basically, it gives us, the conditional probability of surviving at time tj. Okay, when we multiply this quantity, right, that is nj minus dj over nj for all tj smaller than t, then we will get the marginal survival function, or marginal survival of probability. That is the probability surviving from the beginning of study until time tj. Okay. So here, I'd like to work out an example, a simple example. So here, in this case, we have 6 individuals, okay, denoted by ID from 1 to 6. And these individuals, they fail at specified time in column 2. Okay, so either failed or they left the study. So 1 denotes failure and 0 denotes leaving. Here in this case, actually, censoring, right? So for ID1, the first individual, that individual failed at time 2. Let's say, the unit for time is day, so failed at day 2, right? And for the second individual, failed at day 4. Okay, for the fourth individual, okay, well, it survived day 5, then left, and we don't know, when that case or that subject failed. Okay, so this is raw data, right, from the data frame, and here we have second table. Okay, to summarize the information from the first raw table. In the first column, we only list the distinct failure time. That is day 2, day 4, right? Day 2, day 4, day 5, day 7, and day 8. And then in the second column, we'll list the number at risk. So at day 2, how many people at risk? 6. And how many people failed? 1, right? Because when we have, in this case, ID1 failed. And then the next distinct failure time is day 4. And how many at risk? 5, because, you know, one case failed at day 2. Okay, so at day 4, how many failed? 2. Why? You know, that is, you know, ID2 and ID3 failed. Then at day 5, how many at risk? Only 3, okay, because 3 already failed. 1 failed at day 2 and 2 failed at day 4. So we only have 3 left. And how many failed? Well, it shows that, you know, actually no one failed, but we do have one case got censored, right? Yeah, that case, and etc. Okay, and let's continue. Okay, and in this table, I add additional column here, right? To the second table in our previous slide. Okay? And let's read all the bulletin points here. For the first one, the first value of P, here actually is the conditional probability of survival. Why it is 5/6? Well, it is the probability of survival beyond t equal to 2, day 2. Okay, so basically, we see how many actually survived during this time interval. And of course, that includes beyond, right? 6 at risk and 1 failed. So the probability of survival is 5/6, right? During this time interval, right? How about this one? Day 4. Well, how many at risk? 5. How many failed? 2. So what is the conditional probability of survival? That is 3/5, right? 3 survived. 3 survived. Well, it is the conditional probability of survival beyond day 4, given up until day 4, which in this data is the same as the survival beyond day 4, given survival beyond day 2. Okay, thus unconditionally, the probability of survival beyond day 4 is the product of these two probabilities. And that's the reason why in the estimation of the survival function, we have, you know, that pi, right? Uppercase pi, the product. And in this case, well, this unconditional marginal probability of survival from the very beginning to day 4 is half, which is product of 5/6 and 3/5, right? Well, the third value, why the conditional probability of survival is 1, is because on day 5, number at risk is 3. How many failed? 0. How many got censored? 1. So no one failed, all survived. But one case got censored, still survived. So what's the conditional probability of survival on that day is 1, and etc. We can continue. Okay? So unconditionally, the probability of survival beyond day 5 is thus equal to what? Well, we've already figured out the unconditional probability of going beyond day 4. That is half. What we need to do is to multiply that probability with this conditional probability 1, and still we get half. And you know, of course, we can derive the rest of probabilities in this table, and you know, you can try that out by yourself.